And the first step for it is to create a linked heap data structure. So first import the binary node class and create the linked heap class. Initialize it. It has a root and a tail and the size. The root is the heap's root and the tail is the last node of the tail of the heap. So first interface insert. First we create the node and increase the size, and we check if the heap is empty. If it is, we insert this node as its root. If this heap has only one node inside it, which is a root, we will insert this node as the root's left child and upheap it. And then we see if the current tail is its parent's left child, which means the right child of its parent is empty. And then we can insert this new node as its parent's right child and reset the tail and upheap the current the new tail. If the current tail is its parent's right child, then we need to find the new position, find the new parent, which will insert the new node as its left child, and after that we will reset the tail and upheap this new node. Second interface delete. We will first check if the heap is empty, and if it's not, we will swap the old root with the new root with the tail, and then we delete the tail and set since the tail is deleted, so the tail pointer should be reset to the last tail, and we downheap the new root, change the size, and reset the root and the tail if the heap becomes empty. Finally, we return the key value pair. Let's just get deleted. The peak interface, we'll check if it's empty. If it's not, we return a key value pair of the root node. I added a new interface which is get size. Simply just return the size of the heap. And there are a bunch of helper methods here. First, delete leaf. We'll check if this node is the root. If it is, just delete it. If it's not, we will delete it by reset its parent's pointers to none. And swap. Swap two nodes. First, check if these two nodes are the same. If it is yes, do nothing. Then we'll get all the related nodes of these two nodes, and we then swap the pointers of these two nodes. After swap, we need to check if these two nodes are originally connected. If they are, one of their new pointer will point to themselves, and we need to replace it with the other node because these two nodes have just changed their position. And after that, we will swap its related nodes pointers. Also, we will need to check if the related node is one of these two nodes. If it is yes, we just skip it because their pointers are already defined. If it is not, reset the pointers. And finally, we will reset the root at the tail if necessary. Get the next parent for left, which is the method used to find the next position to insert the new node. Here we are assuming that the current tail is its parent's right child, so we need to go all the way up to the left and until there's one node that along this path there's one node that which is its parent's left child. Then we will find its right sibling and go all the way down to the left to find the new place to insert the new node. So get the division right sibling, find the letter right sibling, and find the lowest parent for left, go all the way left down. get the last tail. This is used to to find the last tail when we need to reset the tail. And if the tail is its parent's right child, then its left sibling is the last tail. If it's not, we just which means the tail is its parent's left child, then we go all the way up to the upright until we find along this path there's one node is its parent's right child, then we find its left sibling, and from that sibling we go all the way down to the right, we will find the last tail. So this is what the get division left sibling do, and find the most right, go all the way down to the right. The up heap repeatedly swap the node with its parent if it's smaller than its parent until it stops. Down heap repeatedly swap the node with its main child if it's smaller, if it's larger than its main child until it stopped. So yeah, basically these 4 interfaces. And the next step, we will create a priority queue and implement these 5 interfaces. So import linked heap class and create the priority queue new class. Once initialized, we will set a heap, and interface add, we will use heap insert. Interface remove, we just use heap delete. For the min, we will use heap pick. For it's empty, we will just return if the heap's size is 0, and the length will override the magic method length. So when we apply length function on the priority queue object, it will return the length of the heap, which is size of the heap, which is the number of key value pairs that is inside this heap. So do a test, initialize the priority queue object, check if it's empty, should be true, and add the 7 elements, and then check the length, check the current min, remove for 3 times, and check the min, check the length, check if it's empty again. Let's give it a run. As it's initialized, it's empty, should be true. The length of the priority queue here after add 7 elements is 7. The current minimal is 4, and the 3 times remove in order the elements removed is 4, 5, and 6. 4, 5, and 6. And in the left heap, the current minimal is 7, length is 4, and it's not empty. Yeah, that's it.